I've got f of x equals 4x plus 1. G of x is 4x plus 1. Before we really dive into what we've been talking about, because we can see where the change is, I want to go ahead and graph these two to help illustrate what we're talking about. So they both have an intercept of 1. So let's graph f of x. I'll do that in the blue. So there's that. And my slope is 4. So I go up 4, 1, 2, 3, 4, over 1. Up 4, 1, 2, 3, 4, over 1. So there's my line. If I do g of x, still start at positive 1, except now I go down 4, right? 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. One, 2, 3, 4.
Yeah, but I thought the intersection point was 0.
Intercept is positive 1. So you start at the intercept. And then you count off from there. Now, with this one, we could talk about it being a rotation, and this is where it's a little confusing. But what we also can say is because it's a strict multiplying by negative 1, so because I multiplied the slope by negative 1, guys, because it's multiplied the slope by negative 1, this is a reflection. And if I look, as I go down this line, I can see going right across, every point has a mirror on the other side. This point has a mirror over there. This point has a mirror over there. And that's why we call it a reflection. What's interesting with I noticed looking through your homework tonight, the problems like these actually don't so much say here are to compare them. What they're more likely to say is here's h of x. If j of x is a reflection, what is it?
Reflection.
Right. So if guys, if that's h of x, and I tell you that the new function j is going to be a reflection, how would I write that? How do I change this to create a reflection out of it?
What? Can you repeat that question?
Yeah. Multiply the 3 by negative 1. So that would be the reflection. I take the slope, multiply by a negative 1, so I get negative 3x plus 2. And that's the other collection of kinds of ways they attack this concept.
You should get like whoever like takes down